Hello students. Today we'll discuss one of the most important data structure, that is linked list. A linked list is a linear data structure. It is a collection of data elements called nodes, pointing to the next following nodes by means of references. Each node is divided into two parts, the information part and the link containing the address of the next node. Like see the example. In linked list, you can see here a node is created where the first block is containing the actual information or data part, and the second block will contain the address of the next node. So that way it is connected, one node is connected with the other by means of addresses or references. For example, if the first node is containing data 3, second node is containing data 5, third node is containing data 7. So see why here 1200 is stored, because the address of the next node is 1200. This is containing 1500 because the address of the next node is 1500. And why it is null? Because it is a end or last node. So this is the starting node and this is the ending node. So in this way, a linked list, many nodes can be attached. Need for linked list. Linked list overcome the drawbacks of arrays as it supports dynamic memory allocation. That is, in linked list, number of elements need not be predetermined. More memory can be allocated or released during the processing as and when required. It makes insertions and deletions much easier and simpler than array. So this is the need. As you know, in array we have to give the size while declaring the array. But in linked list, any number of node can be added dynamically because it supports dynamic memory allocation. So what are the common operations in a linked list? There are various types of operations in a linked list, but some common operations: inserting a node in the beginning. We can add a node in the beginning. We can add a node in the end. We can add a node in the middle. We can search a particular node information. We can delete a node. We can count number of nodes. We can find sum of all the nodes and to display all the nodes. So these are the operations. So now one by one we'll see the algorithm for each operation. So algorithm to insert a node in the beginning of a linked list. Suppose if linked list is there where the start is at 1000 memory location, numbers are 3, 5 and 7. Now what is the meaning of adding a node in the beginning? If we want to add a node in the beginning, so that is possible. We can add a node in the beginning. In new node the data will be inserted at the data part, and this node, a link will be established with the existing start. Like this will be connected with this, so this will become a start node. Now let us see. Start. Step 2, check if a starting pointer is null, set it as a start node as. Create a new node and set link to start node. That what we have done here. We have created a new node and here the link part we have set with the start. Start is currently having 1000, address 1000. So now it is connected with this. Okay. And after that, this node we have to make as a start. This will become a start. This we will remove here, and this will become, because now it is the first node of the linked list. Algorithm to insert a node in the end of a linked list. Suppose if linked list is having 3 nodes and we want to add a new node in the end, means here right side. So we can make a new node. In data part we can add the next number which is to be added, and because a newly created node, so this part this link part will be null. Now what is the main thing? Where the null is there, this place if we can set 1400, So this node will be connected with this node. So here we have to set 1400 and it will be connected with this node. So for this, how to write algorithm? Start, check if a starting pointer is null, set it as a start node, as traverse up to last node means we have to move up to the last node, because this link of the newly created node will be attached with the last node. So we are traversing up to last node, create a new node and set link to the last node. Algorithm to insert a node in the middle of a linked list. Suppose we have a linked list with 3 nodes and now we want to add a new node on third number, means after 5 and before 7. So if we want to add a new node here, so a new node will be created. Suppose if we want to add 6 in the new node, so the data part 6 will be stored, because newly node, so this link part will be null. Now what we have to do, currently you can see this node is having address 1500, means it is connected with this node. If anyhow we can set here 1400, so this node will be connected with this. So what we have to do on this place, we have to set 1400. So when you will set 1400, this will be connected with this node. And now where null is there, on this place we have to set the address, this one 1500. So this will be connected with that node. So this will be removed and a new connection will be established. This node is connected with this and now this node is connected to this. So you can see the new node is added in the middle. So algorithm start, check if starting pointer is null, set it as a start node, as traverse up to position where a new node is to be inserted, create a new node and set link to previous node, and for new node set link to the next node. End. Now algorithm to search for a particular node in a linked list. Start, set temporary pointer to the first node, repeat step 4 and 5 until the pointer reaches null. If the data matches with the parameter value, then print details, stop, else move temporary pointer to the next node. What is the meaning? Suppose if you want to search 6, so one by one we will match with the data part. Here 3 is available, we'll move to the next place. 5 is available, we'll move to the next place. 6 is available. So if the data matches with the parameter value, we'll print the details and it will stop. Otherwise, temporary pointer will keep moving to the next node. Algorithm to delete for a node in a linked list. Suppose we have 4 nodes in a linked list and we want to delete 5. So in this deletion, searching process is also involved. Firstly, we will find where is the 5. Once the 5 is found, so what we have to do, currently you can see the previous node, the address is 1200. If on this place anyhow we can set the address 1500, so this node will be connected with this node and this will be removed. So that only what we have to do, where 1200 is stored, on that place we have to set 1500. So in this way, this will be connected to this node and this will be removed. So in this process, this node will be removed and this node will be connected with this node. So start, if first node is, that is the add one, then set temporary pointer to the first node, move the pointer of the first node to the next node and send temporary pointer to null, stop else. Move temporary pointer to the next node, step 4, repeat step 5 and 6 until the pointer reaches null, step 5. If the data matches with the parameter value, then set link of previous node with the next node. That what we have done here. If the data is matching, so we have to set the link of previous node with the next node. And print deleted successfully, stop, else move temporary pointer to the next node. Algorithm to count number of nodes in a linked list. Start, set temporary pointer to first node and counter to 0. Repeat step 4 and 5 until the pointer reaches null. Increment the counter, move temporary pointer to the next node and print the counter value. So how many times the loop will run, counter will increase and in the end we will come to know how many nodes are there. Algorithm to sum all nodes in a linked list. Step 1 is start. Step 2, set temporary pointer to the first node and sum to 0. Repeat step 4 and 5 until the pointer reaches null. Add data value of node in sum variable. Move temporary pointer to the next node and print the sum. This will find the sum. Algorithm to display all nodes in a linked list. Step 1, start. Step 2, set temporary pointer to first node. Repeat steps 4 and 5 until the pointer reaches null. Step 4, print the data value of node. Step 5, move temporary pointer to the next node and end. So like this way, all the nodes, all the information can be printed. I hope you like the video. Thank you.